Welcome to all in this lecture. This is the third video in the series of basic mechanical engineering. In this lecture, we are going to study the Otto cycle. So let's start. Otto cycle. Otto cycle is a air standard cycle of the SI engine. So what does the SI engine means? SI stands for spark ignition. So when the fuel is inside the cylinder, it is combusted using a spark which comes from a spark plug. Such an engine with a spark plug for the ignition of the fuel is known as the spark ignition engine or the SI engine. It is a four-stroke engine. In upcoming videos, we are going to study what are the four-stroke engines and what are the two-stroke engines also. Okay, and also the difference between them. And important thing that the Otto cycle works on the petrol as a fuel. So, see here, this is the schematic diagram of a piston and a cylinder. See, this is the piston attached to this crankshaft. This point is known as the top dead center and this point is known as the bottom dead center. Okay, and this is the cylinder. This is the inlet valve, and this is the outlet valve or the combustion valve. Okay, from the inlet valve, the petrol air mixture enters the cylinder. And from the outlet valve, the smoke and the residues of the fuel remaining after the combustion are expelled. Okay, so let's see the working of the piston and the cylinder. At this point, when the piston is at this point, the attachment is like this, and this position is known as the bottom dead center when the piston is at the farthest end of the cylinder. And when the piston after shift, it moves like this. When the piston comes here after the revolution, it is the top dead center. Touching these vents also. Okay, so let's study the working of the Otto cycle now, and the piston also in the same way. This is the graph of the Otto cycle of volume versus pressure graph. This is the graph from 1 to 2, 3 to 4, and from 4 to 1. We will study how it works. See, 2 and 3, these positions are the positions of the top dead center, and 4 1 are the positions of the bottom dead center. So we will look at how the program works in this graph. From first, when the piston is in the picture, at first air is in this part, it is filled with air. Okay, and the piston is somewhat here at the bottom dead center. From at the start of cycle, the piston is at the bottom dead center. Okay, when we will see here, see, this is our first step. From 1 to 2, what will be the 1 to 2? Okay, the volume is decreasing. Okay, what does it mean? It is compression. Volume decrease means compression, and it is a isentropic compression, that is entropy is constant. And if we look from the point of view of the piston, we will understand that the piston from the bottom dead center moves towards the top dead center, means from BDC to TDC. Okay, this is the first step. What does it is known as? It is known as the 1 to 2 isentropic adiabatic compression, piston from bottom dead center to top dead center. Okay, so now see here, what is the next step? The next step is 2 to 3. At this point, the volume is constant. See here, the volume is constant. Okay, and pressure pressure is increasing. Volume constant but pressure is increasing. Here the heat is added in the cylinder. Heat is added in the cylinder. But how we will add the heat in the cylinder? The addition of heat means the ignition of the fuel. When the piston is at the top dead center, fuel and air mixture, fuel and air mixture is combusted by the spark ignition. By the spark ignition, due to the spark ignition, the temperature rises and we say that heat is added. We say that the heat is added to the mixture. Okay, see here, from 2 to 3, constant volume, at constant volume heat is added, ignition of the fuel air mixture. Okay, from 2 to 3 the ignition of fuel air mixture takes place. Now what is the next step? From 3 to 4, from 3 to 4 the volume increase, the volume increase. Okay, and it is also a isentropic process. What it is? It is an isentropic process, that the entropy is constant. So what will happen in this? As the entropy is constant and volume is increasing, expansion will takes place. And what does the expansion means from the point of view of the piston? From the point of view of the piston, see, from 2 to 3rd the piston was here at the top dead center and the expansion is taking place, so it will come at the bottom dead center. It will come at the bottom dead center and hence expansion will takes place. But while will be the expansion takes place? From 2 to 3 ignition was there, and due to the ignition the piston will move backward, and due to that the expansion will takes place. Okay, and the piston moves from top dead center to the bottom dead center. See here, from 3 to 4, isentropic adiabatic expansion, piston from top dead center to the bottom dead center. Okay, and now the last process. What will be the last process? From 4 to 1. Now from 4 to 1, what will happen? Again the volume is constant. Again the volume is constant, and here from 4 to 1, heat is rejected. Heat is rejected by the cycle. So what does it mean? See, for the start of the second cycle, the piston will be at bottom dead center for every start, and for every end the piston will be at the bottom dead center. And at the bottom dead center, heat is rejected at last. At the final step, heat is rejected. That is, the heat is expelled from the engine. Okay, see here, 4 to 1, constant volume, heat rejection. Now see here, there are some expressions for the Otto cycle. In the Otto cycle, heat rejection and heat addition is at a constant volume, we know that. So the efficiency of the Otto cycle is equal to 1 minus R upon gamma minus 1. Okay, so what does it mean? What does the R mean? First let's see. R is known as the compression ratio. Compression ratio. Generally the value of R is given in the question, you don't need to worry for that, and R value lies from somewhere 6 to 12. Okay, 6 to 12, it is a tentative value. Okay, and what does the gamma stands for? Gamma is a constant which stands for gamma is equal to Cp upon Cv, constant pressure and constant volume, and always Cp is greater than Cv, so gamma will always be greater than 1. So what is the efficiency? Efficiency equal to 1 minus 1 upon R raised to gamma minus 1. Okay, this is the end of the Otto cycle. In the next video we are going to see the diesel cycle. If you like the video, please like, share and subscribe. Thank you.